Okay, welcome back to physics. All right, so um, we are still working on our texting and driving segment, and you had a little assignment to do, and so let's talk about that. All right, so I'm going to go over to our Bitmoji classroom page, texting while driving. Um, And today's assignment or work in class was actually, we went over some things that you were working on yourself. And the first one of those was the Olympics and medals patterns analysis. So, um, Olympic athletes have been improving and improving in most of the major sports over the last 100 years or more. And so this was a little exercise for you to take a look at how athletes have performed and how they've improved and what those patterns of improvement are. So there was this New York Times article that looked at some of the different patterns. And the first one that they chose to look at was how fast men have run the 100-meter sprint. And so we talked about this in terms of uh, how people have done and the level of improvement over time. And that when we look at this over very long periods of time, what we see is that there is a near constant improvement to present day. And that while not exactly linear, that this does provide an example of a linear pattern. So why would we care? Well, way back in the 1800s, men could only run the 100-meter event in about 12 and a half seconds. And now it is considerably faster than that. Why is that? Have we evolved to be faster? Probably not. What we have is improvements in training and technology. So this is an example of something coaches might use to look at how to improve over time. Not all events have gone this way, though. This particular event, the long jump, has been more or less a horizontal pattern. We haven't seen any consistency and improvement. It's been general ups and downs, depending on perhaps wind and who's participating. Um, so why no great improvement here? Perhaps this one really is due to a power function of strength versus body weight and air resistance. And so, because the human body really hasn't changed that much in the last 100 years, we really haven't seen that great a change. Yes, we can improve technology. Um, but in this particular event, it's probably less due to that sort of training. All right, the last one we looked at was in the swimming pool, 100-meter freestyle. And again, there's been some pretty consistent increases in speed uh, from 100, or at least since the 1950s. Okay. And how fast will we get? Well, they predict in here we may get below 45 seconds for 100 meters, which is a pretty incredible race, considering that it wasn't that long ago that people were just breaking 1 minute. And again, so what is causing this increase in speed? It's not human evolution. It is increases in technology, better coaching, so we have better swimsuits. We have better ways to tone muscles and train for races. We have better nutrition. So we were looking at this as an example of not only the patterns, but also the systems, because that's really what we're evaluating in texting and driving. So when we are interested in how do we make a swimmer go faster than 45 seconds for 100 meters, it isn't just get out a whip and make him train harder. We have to look at all the details in everything from the suit that a swimmer wears to the swim cap, their goggles, the way that they start their race, the way that they hold their arm during a stroke, the way that their legs and feet are poised when they're kicking. How much do they kick? What is the size of the kick? How many kicks per stroke? There's all these things that make a difference. And so the only way for us to evaluate this is to take the system apart, evaluate it one variable at a time, and then put the swimmers back together again. It takes an incredible amount of training to make that happen. All right, so the next thing that we looked at was we went over to our actual, um, to our texting and driving example. And in this texting and driving example or work, bring that back up here. We spent some time and did some work in breakout rooms as we moved into our system analysis. So we started with the texting and driving that we were working on last time. And we had a set of slides, and we were working on the final slide, which is evaluating the system for what's involved with stopping distance. And so I asked folks to come up with a bunch of different ideas for that. And so people began to compare with others. And so, just as an example, you may have come up with some of your own, but we came up with things like how fast the car is going, whether the person panics, which foot is actually being used on the brake pedal, um, the reaction time, the amount of distraction. So, what I am asking is that before next class, you take these and move them into this column, group them up under the three categories of braking, reaction, and uh, uh, distraction. Okay. And then the final two columns, for each one of these variables, what do we need to know and how are we going to measure it? So there's some easy ones, for example, the speed of a car. All right, well, we need to know the speed and we're going to set that as a variable. How are we going to measure it? Well, we're actually going to measure speed. Others are a little more difficult to come by. Weather, we know weather affects stopping distance. Is it icy, snowy, rainy, clear? So what do we need to know? Well, we kind of need to know the weather. Which weather patterns do we really care about? And then how are we going to measure those? So that takes some thought. So I'm asking that you get that done tonight. So that's what we were working on today. And I will see you next time.